All right, so today should be Wednesday, March 2nd, and this is volumes of a revolution, the disk and the washer method. So we're finding volume. You found volume in geometry. You had a lot of formulas. You had formulas like area of the base times the height for a prism. You had 1/3 pi r squared h for a cone. You had pi r squared h for a cylinder. You had 4/3 pi r squared for a sphere. All these formulas. When you're looking at a prism, the formula makes sense. Area of the base times the height. So I have the area of the base, and then when I multiply by the height, that's like sticking up a whole big stack of the exact same squares to get the volume. You can also think of it as, I'm going to take it and slice it up into some itty bitty 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 slices, and then stack all of them on top of each other, and then just kind of add up those infinite number of little slices that you make. So that kind of goes with the cylinder. It's the same idea, pi r squared, your circular base times the height. But the cone and the sphere are weird. They got this 1/3 and 4/3 and all that stuff in there. And if I was the one teaching you geometry, I would show you where every single formula came from, except for those, because they're calculus based. So, we're going to look at this equation. Y equals 16 minus x squared. Do we know what that is? Do we know what that's going to graph? 1, 2, 3, 4 this way. 1, 2, 3, 4 that way. There's no plus or minus, it's just the positive square root. 1, 2, 3, 4. This is going to make a semicircle. I'm going to check the camera. I'm walking right in front of the camera to make sure that you can see the graph just fine. Yeah, you can see it well enough. Okay. So we've got this semicircle. So here's the idea. If I take a semicircle, okay? If I take this semicircle, you got to visualize, and rotate it around the x-axis. So I'm taking this semicircle and I'm going to rotate it around the x-axis. Do you know what three-dimensional shape that's going to make? I'm taking my semicircle. All right? I'm taking my semicircle here. And if I rotate it, oh no, it fell. If I rotate it around the x-axis, all the way around 360 degrees, I'm going to have a sphere. Flat, two-dimensional semicircle. Rotate it around the axis, and it's going to create a three-dimensional solid. And that's the idea, is that we're going to be rotating regions where all we've done so far is found area of those regions. But now I want to take them and rotate them, either rotate around the x-axis or rotate around the y-axis, create a three-dimensional solid, and then find its volume. So the idea with the sphere, so think about it kind of like the prism. If I take it and start cutting and slicing it up into an infinite number of slices, what's one thing that all these slices are going to have the same? Slice it up, slice it up, slice it up. They're all going to be circles, but are they all going to be the same size? The circle I cut way over here in the end, is that going to be the same size as the one that I cut in the middle? No. So it's an ever-changing radius. But that's the idea, though. I want to add up all these circles from here to here. And that's the basis for our formula here. I told you before I left that this chapter here, this chapter 6, is very formula based. So these are my two formulas for the disk method, or revolving around the x-axis and revolving around the y-axis. You're not going to get to pick what axis to rotate around. You're going to be told which axis to rotate around. So whenever we were doing area last time, area between curves, you got to pick whether you wanted to integrate with respect to x or with respect to y. And sometimes one way was easier than another. You know, this one was already x equals a bunch of stuff with y, so we just left it like that and integrate with respect to y. In this case, they're telling you what axis to rotate around, which means they're telling you what letter to use, what variable to use. So when you're rotating around the x-axis, you're going to use x's. When I rotate around the y-axis, I'm going to use y's. It's not your choice what to do. Okay? When I'm revolving around the y-axis, everything has to come from y. We have a dy here. My function needs to be x equals stuff with y. And when I say that, x equals, maybe it's going to look, maybe it'll look like this. Maybe it's a vertical line and looks like this. It's still x equals, technically, y to the 0. It's still x equals stuff with y. Okay? You don't have to see a y for it to be in the right form. It just has to be x equals to go in here. And then we've got the y1 and y2. That's the same thing that it was before, where your region starts and stops. And then we got a pi out here. So it's pi, and then my function is acting as the radius. So if we take this, if you think about this, 1, 2, 3, 4, my semicircle here, and then I rotate it, so it's going to make a sphere, all right? It's a sphere. The radius of the sphere, this is the center of rotation. My x, I'm revolving around the x-axis, so the x-axis is my center of rotation. From the center of rotation out to the edge of the sphere that I create when I rotate, that's my radius. Well, it starts on the x-axis and ends at the function, so that is a y value. That is my function. Y equals f of x, okay? So when I'm using x's, everything's with x coordinates of intersection points, pi function squared. Pi function squared is pi r squared. And integrating is going to add all those up. Think about when you first started integrating, you were adding up rectangles. You're adding up that infinite number of little slices, of little rectangles, basically. If you don't understand why, you don't have to understand why. Understand these formulas. Okay? Understand these formulas. One thing you need to know is that on the AP test, there are 6 free response questions. One of them is always completely devoted to this stuff that we're doing here in this chapter, area and volume. It's not going to get super crazy difficult. They're not going to ask you to explain your answer or things like that. So that's the one free response question that you should just knock it out of the park and get all these parts right. Because it's not, there's not a whole lot of analytical, analyzing, stuff to it. All right, so let's look at this one. Find the volume of the solid created by rotating the region bounded by y equals square root of x equals 9, and y equals 0 about the x-axis. So, they're telling me I'm rotating around the x-axis. So now, I'm going to go ahead and start writing my integral. Pi function squared dx. And I know this has to be y equals stuff with x, and these need to be x coordinates here. So when I take and I graph square root of x, 0, 0, 1, 1, 4, 2, 5, 6, 7, 8, 9, 3. And then it says x equals 9. That vertical line is also a boundary. Pretend like I just drew a straight line and not the super crazy crooked stuff that I just drew. All right. And y equals 0. What is y equals 0? Y equals 0 is my x-axis. So this is the region that I'm using. I'm going to take that region, I'm going to rotate it around the x-axis. Now, you do not have to be able to visualize what it looks like. That is not important. But but sometimes it helps. This is very little. I'll come closer to the camera. Think of that as my square root curve. I'm going to rotate it around the x-axis. Rotate it. Oh, come on. Rotate it around the x-axis. Now this one is a lot thicker than that is, but you kind of get the idea of what it looks like. If it was long, if it was a little bit longer and skinnier, a lot of my students in the past have said it looks kind of like a bullet. You know, whatever you want to say it looks like. But that's basically the idea. But if you can't visualize that, that's okay, as long as you know the formula. Pi function squared. What function are we using? Square root of x. If I look at this, and when we were doing area, sometimes I would say you need to draw a vertical strip in there to see what this top part is, what the bottom part is. If I draw a vertical strip in here, here's the axis. What am I touching? That's my radius. My function is the radius. Now, limits of integration. What are the x values for where I start and stop? 0 and 9. That's where I'm starting and stopping. 0 and 9. There's the setup. That's the concept that we're using today. I would go ahead and square that out, which is always going to be your first step on any one of these problems, is square the stuff out. Oh, no integration symbol. We're done with that. Let's integrate. So I'll have 1/2 x squared from 0 to 9. So I'm going to plug in a 9. I'm going to plug in a 0. And I get 81 pi over 2. I'm going to check the camera. Let's see how y'all can see that. I can't see from over there. Maybe I shouldn't use green. That looks like it's a little hard to see. I'll use a different color next. All right, let's take this same region and let's rotate it up. Nope, we can't do that yet. No, never mind. Forget it, we're not gonna do that. Next. Next. Find the volume of the solid created by rotating the region bounded by y equals x cubed and y equals 8 about the y-axis. Alrighty. X cubed. 0, 0, 1, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. There's the line y equals 8. So I'm rotating around the y-axis, so it is assumed that y-axis is also a boundary. So this is my region. I'm going to rotate around the y-axis. This is going to be a very similar shape to what we just had. This is just longer and skinnier than the other one. And the other one was laying flat. This one's vertical. So they tell me which letter to use. They said rotate around the y-axis. That tells me I have to use y's. dy. So pi function squared. What's my function? Y equals x cubed. Can I write x cubed in there? No, I can't, because I cannot have x's and y's together. I'm only using y's here, integrating with respect to y. So I got to take the y equals x squared, x cubed, and solve it, get it x equals. So you can write it as cubed root. I say write it as y to the 1/3 because you're going to want it like that to be able to do your power rule. And then my limits of integration. Where am I starting and where am I stopping? I'm starting at 0. And then do I say 8 or do I say 2? 8 or 2? 8 or 2? 8, because that's the y value. And that's how we're setting that up. We're going to go ahead and square it out. Y to the 2/3 dy. 5/3. If I plug in a 0, I'm gonna get 0. 8 5/3. Cube root 8 is 2, 2 to the 5th is 32, times 3, 96 power 5. These are volumes, but we are not going to be putting units on our answers. Usually because you're not given any units. Because we're just on a graph, it's just kind of cubic units. Yeah. It's kind of a cubic units kind of thing, but I'm never going to ask you to write cubic units. You're never asked on the AP test to write cubic units. It is, sometimes this problem is on the calculator part, sometimes it's on the non-calculator part. So you need to make sure that you're prepared to work it with and without the calculator, without graphing with the calculator, finding intersection points with the calculator, besides just integrating with the calculator. Your test is going to be half and half for that reason. Let's look at this real quick. And let's say this is a problem with the calculator. Alrighty? Region bounded by y equals square root of sine x. We'll just say first quadrant. Just to make sure I'm being specific enough about what region we're using. About the x axis. I'm gonna come look at the camera again. I'm sorry to get my face in the middle of the camera. All right, yeah, that looks good. Okay. So, if I have my calculator, I'm going to rely on my calculator as much as possible. So if I do square root of sine x, I better be in radians. I am graphing in radians. So I need to know that point right there where it intersects. Now, if I try to find zeros, I don't know how well that's going to work because there's nothing below the axis. But I'm going to try it. Yep. 3.1415926535. I hope that number sounds familiar to you because it's my favorite number. Come on. So, find the volume of the solid. I didn't write find the volume. That's all we're going to do is find volumes. Around the x-axis, so that's dx. Square root of sine x from 0 to pi. So let's say this is the calculated part of the test. I expect you to write this down. I don't expect you to tell me how you found pi right here. That's not important. And then if you want, you can totally integrate it with the calculator. We have this saved as y1. Oh, man, I'm dropping my calculator. Numerical interval from 0 to pi, square root of sine x, dx. And this is one where I would have to integrate it with the calculator. We do not have the skills we need to integrate something like this by hand. And that's generally what we do on the AP test. Usually the stuff on the calculator part isn't stuff that you could integrate by hand if you wanted to. 2.396. So this is all the work you would have to show on the calculator part of the test. Setup and answer. But your setup has to be completely right. You gotta have your pi here. You gotta have your my answer's wrong. Why is my answer wrong? Why is my answer wrong? What did I forget? I didn't multiply by pi. Now, I could have taken the answer that I had there and just said times pi. But I wanted to do it like this. You gotta have that pi on the outside. I forgot it, so that would be wrong. This would be right, 7.528. So make sure you have everything here. Make sure you have your dx, have parentheses in the right place. If you wanted to go and simplify this and just say sine x dx, that's fine. All right. Find the volume of the solid. Region bounded by this. We need it equal to, right here, greater than or equal to -1 about the y-axis. So if I want to find this volume, I could, and I'm using this, and we're using the calculator, because I don't think I showed you how to graph this stuff in the calculator last time. That's a parabola facing to the left. So even if you were making a T-chart, you should expect after you graph it that it should be facing to the left, a parabola facing left. Just going to clear out everything here. When I go here, I'll go menu, graph entry edit, equation, parabola, and mine is not in vertex form, it's in standard form and not y equals but x equals. So that's choice 4. And then I just got to put in the coefficients. So the first was -y². I can't just put a negative. I have to put -11, a -1 in the blank. So don't just put a negative. -1. Make sure you use the negative sign, not the subtraction sign. And then 4y. And then I got to fill in that last blank, and that is a 0. And so I hit enter, and there's that graph. So we want this, x equals 0. Oops. Right here. Wow, that's really big. Biggest graph ever. Okay. So that graph x equals 0, so that's the y-axis, so that's a boundary. And then y equals 1 is a boundary. And then it specifically says greater than or equal to 1. So that's how I know I want this bigger volume instead of this little bitty kind of triangular looking volume right there. So rotating around the y-axis, pi, function squared, dy. My function is -y² plus 4y. Intersection points, remember that you're using y coordinates. We start at 1 and end at, what is that, 3 or 4? 1, 2, 3, 4. You can always set that equal to 0 and solve. You would factor out a 1, set each factor equal to 0. So this is what I'd be integrating. If I'm going to do this on the calculator, which I might do a lot of this on the calculator just so it doesn't take me so long, because I'm already tired of setting it up already. And I just marked ink on the calculator again. Calculus, numerical integral. So from 1 to 4. All right, okay. Oh, pi. Don't forget the pi in the front. Maybe y'all were yelling at me. Don't forget the pi. There's the pi. So -y². I can type y, I can type x, I can type whatever letter I want. As long as I put that same letter over there in the D, where normally put dx. You put the right letter there. That's why that's why the calculator wants you to fill that in. So you're telling it what variable you're using. I'm going to square that, dy. Pi, integral from 1 to 4, -y² plus 4y, all squared dy. If I was doing this by hand, I would have to square out that binomial combine my like terms, then integrate every term, plug in the numbers, multiply by pi. This is how we're doing with the calculator, 96,133. I said I wasn't going to use green anymore, I'm using green. There you go. Now that one we did a minute ago where we forgot to multiply by pi. One option that you have, if you already wrote down the answer, and you're like, oh, I didn't multiply by pi, just slap a pi on the end. Just write pi on the end of it, and that's perfectly acceptable. All right. Any questions? No, of course not, because I'm not really. Find the volume of the solid. Generated by rotating the region bounded by y equals x squared plus 2x about the x-axis. I'll give you just a second to get that written down. I can always pause the video to give you time to write down the problems. If you need more time, rewind it or pause it right now. I'm about to go to the calculator. I'm going to go ahead and not mark on the calculator ever again. I'm going to clear everything out in doc B real quick. So I'm graphing x squared, so I'm going to put that one in first, just because it's listed first. No other reason than that. X squared negative x squared plus 2x. There's an little bitty area between those two curves. Let's blow it up. Move these labels around so we can see a little bit better. So, this is my region. So I want to rotate this. What did it say? Rotate around the x-axis. So rotate there and create a solid. Let's see if I can find. No. It'll be on the other flash drive. I want to see if I can find I have an illustration for this. Why can't you play my movie? Let's try this one. There we go. All right. So there's the region rotating, and the whole thing rotates around. And then it stops. It doesn't let you look at it. There you go. I'm going to try to save those in the same folder where this video is saved in case you want to look at it again a little closer up. But my issue here now is that when I go to slice this up, I'm not going to have circles. I'm going to have a circular shape, but not a circle. Let's go ahead and find the intersection point. 1, 1 is the intersection point. So this is my region. And so when I rotate it, all right, we'll have circles here, okay? So, and then you're going to have little circles made from the little part, from the inside part. So if I sliced it up, instead of having a solid circle, I'm gonna have what's called a washer. Chunk washers, play that game, chunk washers, looks like that. If you're hungry, it looks like a donut. So I need a different idea to get this volume. What would I do to take this area, which you did first, that was last time, How would you just find that area? Area, you would integrate top minus bottom. dx, x coordinates of the intersections, because we said we're doing big area minus little area. Same idea here, but I'm going to do big volume minus little volume. So it's going to go like this. This is my washer method. These are my formulas for a washer method. And I'm writing this in green. And I said I wasn't going to write in green because it didn't look like I could see green very well. All right, so x-axis, washer method, pi. X coordinates of intersections. Top function squared minus bottom function squared. You're doing two volumes and subtracting. Big volume minus little volume, which you did in pre-cal, to like find the volume of like a roll of paper towels where it had the part in the center. So you would get the area of the whole thing, area of the center, and subtract it out. So pi function squared is one volume. Pi function squared is my other volume. So you're still going to do top minus bottom. So it's kind of like taking last time and what we just did with the dis method and marrying them together. So we're on the y-axis. It wouldn't be much different. I have my pi, y1, y2, and then instead of top and bottom, right squared minus left squared dy. Those are your formulas for washer method. Just learn the formulas. We're always using right and left with the dy, top and bottom with the dx. So in this situation, I'm integrating with respect to x, going around the x-axis. So I would say pi integral from 0 to 1, which in this situation you get lucky because it's 0 to 1 on the x's and 0 to 1 on the y, so you can't really mess that up. And then what's the top function? That top function is that red one, which was the negative x squared plus 2x. Square that minus the other function was x squared dx. I do not subtract and then square. I square and then subtract. I square to get volumes. I'm subtracting to volumes. Do not subtract first. That's the easy way out. And this is math, and math is hard. All right, so this is the way we would set this up. I really don't want to work this out by hand because I'm tired of standing up. So we would square this out, square this, combine like terms, get a bunch of terms, integrate. You would just do the math. I'm just going to cheat and look over here and see on my notes thing what the answer is. So that's pi over 3. So there you go. That's the idea for washer method. Here's the formulas written out real nice. Typed up real nice, I should say. So, write those down. You already have them written down from the other page. You can go back to this and write them down again. Just notice that you square them both first, and then I subtract. Square them both first, and then subtract. Find the volume of the solid generated by rotating the region bounded by y equals x squared plus 1, y equals 0, x equals 0, and x equals 1 about the y-axis. rotate around the y-axis. So already, I know I'm going to be using dy. Function squared minus function squared. You can do something like this, kind of write yourself a shell. That way you're sure to square them both separately before you start just writing stuff down. And then whatever my y-coordinates of my intersection are. I'm going to graph this one over here. Let's see about doing this one by hand. This is easy to graph. I'm going to make double the scale over here to make sure y'all can see this good. So x squared plus 1 is going to start here. 1, 1, 2, 1, 2, 3. Right here. Okay. It's probably enough graph. Y equals 0 and x equals 0. That's my x and y axis. All right. X and y axis are part of my boundary, and then x equals 1. Another part of my boundary. So it's this one. Still not very big. That point, you know, that's 1 right there. That point there is 1, 2. There's a 1 right here. So when I'm rotating around the y-axis, I need to be using y's, which means I need to be thinking right minus left. Well, if I look at this, if I was just thinking about area, which hopefully you all practiced that area homework, and you got that concept down. When I look at right and left, here right side is x equals 1. Here, left side is the axis. As I move up, right side is x equals 1, but the left side is x squared plus 1. So since I have different lefts and rights, this is going to have to be 2 separate intervals. Still using y's though. So I need to go ahead and take this and get it x equals. I don't need a plus or minus because I know that I'm using the positive part of the curve. We wouldn't put a plus or minus in an interval anyway. You would have to decide, am I using the plus, am I using the minus? And if you're using both, then you put them in 2 separate intervals. One interval with the plus, one interval with the minus. So I'm going to integrate. So this first part, from 0 to 1 on the y's, the right side is x equals 1 minus the left side is the axis y equals 0. You can also look at this and say, well, this is just going to be a cylinder. It's going to be a complete solid cylinder when I rotate it. And you can just use geometry to find the volume of the cylinder, kind of like on some of the area problems we did before we did geometry to get like the area of a triangle. You wouldn't have to integrate. All right? Plus the other interval, pi from 1 to 2. Well, now the part on the right is still 1 minus the part on the left is now square root y minus y. Squared dy. It's a minus 1 right there. Hopefully y'all can see all of that. Yeah, maybe, hopefully. All right. So I ended up with 2 separate intervals, which is not very nice. We're going to revisit this problem next time, and we'll do one interval with a different method. Pi from 0 to 1. This first part is just a dx. Plus pi from 1 to 2. 1 minus y minus 1. Let's go ahead and simplify this. What's a plus? That's a plus. Negative y plus 2 dy. y. Now we're ready to integrate. So this would be a pi x from 0 to 1, so I'm integrating a 1, plus pi, not x, dy. Why did I put dx? Dy, we're going on the y-axis, y. So I won't have pi x. I'll have pi times y. Sorry. All right. Negative 1/2 y squared plus 2y from 1 to 2. So when I plug in my 1, I get a pi. Plug in my 0 is 0. Plug in my 2, I get negative 2 plus 4 minus, parentheses, plug it in 1, negative 1/2 plus 2. I have a pi here. Two minus 3/2. All right, so that's pi over 2. So 3 pi over 2 is my volume for that one. We had to split it up for the same reason why we had some areas that we had to split up into 2 areas, that they didn't have consistent regions on both sides. My right side changed at some point as you were moving up with your strips, adding up that infinite number of strips. All right. Volume of the solid generated by rotating the region bounded by y equals x squared, y equals 2x, about the line y equals 2. Now, these are things that you're definitely going to see on the AP test. They want you to be able to revolve around something that is not an axis. There's more than one way to go about this. I only do it one way because I'm good at that way. The other way, I'm not good at it, so I'm not going to do it the other way. If you're getting tutoring from someone, especially Rick, if any of you started going to Rick Gibson while I've been out, he definitely does it the way I'm not good at it. I can tell you that much. And that's okay. X squared, and what was the other thing? 2x? Y'all can't answer me, you're not here. Yes, y equals 2x, and x equals 2. We're going to need that. 2x. So to draw a vertical line, then you graph entry edit, equation, line, vertical line. X equals 2. And it's the same color as that other one. I don't like that. I'm going to change the color. Could move some of these things around. Let's make it green. Move that a little bit. Move that label a little bit. Move that label a little bit. All right. And let's zoom in a little bit. All right. Okay. So this is my region that I want to rotate. And this is going to be my axis of rotation. The formulas I gave you only rotate around x and y axis. We're not rotating around x and y axis. So my strategy is to shift my functions so that this turns into the y axis. And then I know how to do that. So this is x equals 2. So I want x equals 2 to be the y-axis. So I got to shift to the left. How much am I shifting to the left? 2 units. How do I shift 2 units to the left? What do I do with y equals x squared to make it shift 2 to the left? X plus 2 squared. You put a plus 2 directly in there where x is. So these are my two new equations. So normally, when we're dealing with y's, we subtract right minus left. It's not really right minus left always. It's always furthest from the axis minus closest to the axis. And usually, our regions are over here in the first quadrant, where we're going here minus here. But when I shift, now I'm going to be over here in the third quadrant. So you're going to take what's furthest away from the axis of rotation, put that in the interval first, square it, and then subtract the one that is closest to the axis of rotation. So we're going to have the line first. And you can simplify this first. Or, especially if it's a calculator part of the test, you don't have to do any of this algebra. You don't have to distribute that, just write that. Minus, and then the parabola, x plus 2 squared, squared. The x, right, rotating around the x-axis? No. We're not rotating around any axis, but what did we shift it to be? We shifted to make it the y-axis. I need to be using y's. I messed up again. I think I'm just trying to go too fast, so I can hurry to get done. So if I take y equals 2x plus 4, so that's my line. Y minus 4 equals 2x, 1/2 y minus 2. So there's that equation. X plus 2 squared. Take the square root. Since I'm using this half, the right half of the parabola, that is the positive square root part. So x would be -2 plus square root of y. So those are my equations. Line, whoops, that's not negative. Line squared minus parabola squared dy. Now I need limits of integration. Y coordinates of the intersection points. They started at 0, and this is x equals 2, so the x is 2. Plug that in, the y has to be 4. Yeah, 0 to 4. If you were doing that by hand, you would square out this binomial.